You know that feeling, right? That dreaded orange glow on your dashboard, the check engine light. It can mean a really expensive trip to the mechanic, or maybe a chance to get your hands dirty. What if I told you that you could fix it with a clever little electronic device that you built yourself? Well, today, that's exactly what we're diving into. So, how do we get from that pesky warning light to a DIY fix? Here's the game plan for today. First, we're going to really understand the problem itself. Then, we'll introduce the hero of our story, the EGR emulator. We're going to uncover the super clever trick it uses to fool your car's computer, look at 2 different ways you can actually build one, and finally, break down the key parts you'll need. All right, let's pop the hood on this thing. The culprit, a lot of the time, is the exhaust gas recirculation system, or EGR for short. Now, it's supposed to be a good thing. It's part of your car's emission controls that lowers temperatures inside the engine. But, sometimes the solution to one problem ends up creating a whole new one. And that brings us to the big, frustrating question every driver has asked at some point. Why won't this light just turn off? See, the EGR system is supposed to help, but over the years, all that recirculated exhaust gas can cause some serious headaches. And this quote from a user on an electronics forum just hits the nail on the head. Imagine opening up your engine's inlet manifold, which is basically the lungs of your car, and just finding it choked with this thick black gunk. That's carbon built up from the EGR system, and that mess is exactly why people start looking for a way to get rid of it. Okay, but here's the catch. You can't just rip the EGR valve out. Your car's brain, the engine control unit, or ECU, is way too smart for that. It'll know something's gone, and it'll keep that annoying light on. So, what's the solution? Well, it's time to enter the cheat code. And that cheat code is the EGR emulator. Honestly, just think of it as a little electronic liar. Its only job is to feed the ECU the exact signals it expects to see, tricking it into thinking the EGR valve is still there and working perfectly, even when it's not. As one forum user put it so brilliantly, it's a cheater circuit. It doesn't actually do the job of the EGR valve. Nope, it just fakes the electronic paperwork to keep the ECU happy and, most importantly, to get that light off your dash. So, how does this tiny device pull off such a clever trick? Well, the secret is in understanding a surprisingly elegant bit of logic. It's not about faking just one signal. It's about outsmarting a very clever cross-check that the ECU performs. This right here, this is the ECU's secret handshake. Okay, so when the EGR valve is closed, the engine is breathing in maximum fresh air, right? The mass airflow sensor, the MAF sensor, sends a high voltage signal. But when the ECU commands the EGR valve to open, exhaust gas rushes in and that pushes out some of the fresh air. The ECU expects this to happen, so it looks for one thing. It looks for the MAF sensor's voltage to drop. If that voltage doesn't drop when it's supposed to, boom, check engine light. And that is the key to the whole trick. The emulator is basically a spy. It's listening for the ECU's command to open the EGR valve. The second it hears that command, it springs into action and artificially yanks down the MAF sensor's voltage signal. It's a perfectly timed little electronic heist. Okay, so now that we've cracked the code, let's look at how people have actually put this into practice. There are 2 main ways to build these emulators. And while they both get the same job done, they take slightly different paths to get there. And here they are, the 2 contenders. Over on the left, you've got the beautiful simplicity of a passive circuit. And on the right, a more advanced active design, which has a transistor as its centerpiece. Both are listening for the exact same signal from the ECU, but they have totally different ways of manipulating that MAF sensor signal. First up is the passive design. And it's just beautifully simple. When the ECU says, hey, open the EGR, this circuit just uses that very signal to create a little detour for the MAF signal, sending some of its voltage to the ground through a resistor. It just bleeds off enough voltage to make the ECU happy. Simple, but it works. Now for the active approach. This one's a bit more sophisticated. Here, the ECU's command goes to a transistor, which acts like a super fast electronic switch. When it gets the on signal, it just flips, connecting the MAF signal to ground through a couple of resistors, and poof, the voltage drops. This gives you much more precise control, which is really important for the pulsed signals, what's called pulse width modulation, or PWM, that a lot of modern cars use. So what are the magic ingredients that make these circuits actually work? Let's open up our electronic toolkit and take a look at the key components you'd need for that active version. At the very heart of the active circuit is the BC337 transistor. This little guy is the brains of the operation. It's the electronic switch that's always listening for the ECU's command, just waiting to spring into action and connect the MAV signal to the rest of the circuit. Next up, we've got the 1N4004 diode. The best way to think about this is like a bouncer at a club. It only lets electricity flow in one direction. It's a super important safety feature that protects your expensive MAV sensor from any electrical current trying to go the wrong way down a one-way street. And finally, we have the resistors. These are basically your tuning knobs. By picking resistors with the right values, you can dial in the exact voltage drop you need. This lets you fine-tune the circuit to perfectly impersonate a working EGR system for your specific car model. So what are the big takeaways here? Well, first, modern cars are smart. Their computers are constantly cross-referencing sensors to make sure everything's running right. Second, the logic to fool them is surprisingly simple and really kind of elegant. And most importantly, this whole project just goes to show that sometimes the best solution isn't brute force, but a little bit of clever electronic wizardry. And that really brings us to our final question. We've seen the incredible cleverness that goes into building a circuit like this. But where do you draw the line? Is this a brilliant engineering hack to solve a messy, flawed system that can gum up our engines? Or is it just cheating the system? I'll leave you with that to think about.